Hello everyone and welcome to yet another episode of Darko's Game Dev Cookbook. Today we'll be talking about a rendering technique called ray marching. And although its name is similar to its big brother ray tracing, it's not to be confused with. It's gonna be an interesting one, so stay tuned. So what's the big fuss about? Why is there a thing called ray marching and how is it different from ray tracing? Firstly, if you don't know what ray tracing is, I strongly suggest you watch my tutorial covering ray tracing basics beforehand. The link should pop up somewhere above. But in short, ray tracing is a rendering technique that consists of shooting a bunch of rays from an imaginary camera to a so-called canvas. The canvas itself is actually what will end up on your screen, and it's split into pixels. Each ray goes from the imaginary camera through a specific pixel on the canvas. If the ray hits something, we just color the pixel of the canvas it went through. But how do you know if the ray actually hit something? We do so by using math, more precisely by using intersection formulas. For example, if you wanted to draw a sphere using ray tracing, you would shoot a bunch of rays from your camera and perform a so-called ray-sphere intersection. This is nothing but a math calculation that determines if a straight line intersects with a spherical body in space. Ray marching, on the other hand, does not deal with these intersection formulas. Instead, it uses so-called sign distance functions, or SDF for short. SDF is nothing but an expression that gives you the distance to the surface of the object described by it, from any given point in space. In code, SDF will be nothing but a simple function taking a position and returning a distance. So, for example, if you had a point and a sphere in 3D space, and you invoke the sphere's SDF by passing it the point position, you would get the distance from that point to the surface of the sphere. I will talk more about SDF in one of my future videos. Okay, now you know what SDF is, so we can start with ray marching. The main difference between ray marching and ray tracing is that instead of just shooting these rays into infinity, we sequentially prolong them, or we march. What does that mean? When we shoot the ray, the first thing we do, instead of calculating this ray object intersection things, we calculate which object is the closest to our current point of inspection, using those objects as SDFs. So you know, using these SDFs, how far each object from your point is. That distance then becomes the size of your next ray march iteration. We keep repeating this process until the distance is below a certain threshold, or simply until our ray goes too far. If you do manage to get below a certain value, that means that we have an intersection and we paint our canvas pixel appropriately. The main power of ray marching is in how easy it is to manipulate sign distance functions. So if you just compare the intersection function and sign distance function for a sphere, for example, you quickly see how simpler SDF is. Another thing with SDF is that it can be combined and result in some crazy shapes and fluid-like objects that are pixel perfect. That's really hard to do with ray tracing. So ray marching is the way to go if you want to do crazy stuff. And that would be all for today. Now you know what ray marching is. I hope you enjoyed the lesson. If you like the content I'm creating, please do hit that like button, it means a lot and it's for free. I will be covering ray marching in more detail in the practical tutorials here on my channel, so make sure to subscribe to stay up to date. Until the next time, enjoy!